The factor theorem is a cousin of the remainder theorem. In fact, it is derived from the remainder theorem because the remainder theorem says if x minus a is not a factor of f of x, then the remainder is f of a. That's what the remainder theorem says. So if you divide f of x by x minus a, the remainder is f of a. So in this case, if x minus a is a factor, obviously the remainder is going to be 0. That's why f of a is equal to 0. So if you understand the remainder theorem, you will not struggle to understand the factor theorem, because the factor theorem is essentially the remainder theorem for a case where the remainder is equals to 0. So I'm just going to explain how you can prove that a certain function is a factor of another function. In this case, I'm going to give you an example where one of the functions is a polynomial and then the other is a linear function. And the linear function is the factor. Let me illustrate this with an example. You are required here to prove that x minus 4 is a factor of uh, 2x cubed. Let me write it here. 2x cubed minus 11x squared plus 5x plus 28. This here is our x minus a. So this is x minus a, and the polynomial is our f of x. We want to prove that x minus 4 is indeed a factor of 2x cubed minus 11x squared plus 5x plus 28. We want to prove that, and we're going to rely on the factor theorem. This is how you do it. Okay. Let's start by writing our statement, the factor theorem statement. If x minus 4 is a factor, if x minus 4 is a factor of f of x, and our f of x is 2x cubed minus 11x squared plus 5x plus 28. If x minus 4 is a factor of that, then f of a let me write this as f of 4 should be equals to 0. In this case, it means 4 is my a. My a is 4. Let me explain again how you get your a. All you do, you go to the number that is being called the factor. In this case, it's x minus 4. You equate it to 0. Then you solve for the x. If I solve for x here, I get x is equals to 4. And this 4 here is my a. This is what it means. So it's easy for you to get your a. Whatever function you are being given as the factor, you equate it to 0, you solve for the x, then that x is going to be your a. That's it. So f of 4 should be equal to 0. If it's not equal to 0, then it means x minus 4 is not a factor. Now let's find f of 4. F of 4 is equals to, we call this the functional notation. When you say f of 4, you go to the function that is being called f of x, and you substitute 4 for x. Every place where there is an x, you put a 4, then you punch your calculator, and you get f of 4. If it is not 0, then you can conclude that x minus 4 is not a factor. But if it is equal to 0, then you can say, oh, x minus 4 is indeed a factor. Let's do that. So it means here we're going to have 2 4 cubed minus 11, 4 being squared, plus 5 by 4 plus 28. If I punch all this in my calculator, I should get a 0. If I don't get a 0, I'll conclude that x minus 4 is not a factor. So let's do this. 2 times 4 cubed. 2 times 4 cubed minus 11 by 4 squared plus 5 by 4 plus 28. It is indeed equals to 0. So I got a 0 here. Now, once I have this, I can now conclude. Therefore, this is my conclusion. Therefore, x minus 4 is a factor. That's it. I have proved that x minus 4 is a factor of 2x cubed minus 11x squared plus 5x plus 28. I have proved that. So when you are writing the solution to this question, make sure you include the if statement, this statement here, include it. Then do the working and then write your conclusion. So if there are 3 marks, I'll give you a mark for writing the if statement. Then I'll give you a mark for doing the substitution, and then a mark for writing your conclusion that it is a factor or it is not a factor. Let's go to, let me do another example here. The 2x, prove that. So we are prove that 2x minus 1 is a factor of 2x cubed plus a 3x squared plus 10x minus a 6. Now, this is the 2x minus 1 is our factor, and this polynomial is our dividend. We are going to divide into it, obviously, and we want to prove that 2x minus 1 is indeed a factor. We know, guys, that if we divide a number by its factor, the remainder is 0. That is a fact. That's why I'm saying the factor theorem is indeed a cousin of the remainder theorem. In fact, it is just saying if this one is a factor, the remainder is equal to 0, or f of a is equal to 0, which is the remainder, by the way, from the remainder theorem, if you still remember. Now, I have to get my a. Forgive me here, I'm not going to write my if statement. I'm not going to write the if statement, but I'm going to find my a. I said if you want to find your a, you take your dividend, or the factor, you take your divisor, 2x minus 1, you equate it to 0, and you solve for x. If you solve for x here, x is equals to 1 over 2. This 1 over 2 becomes your a. That's your a. Okay. Let me now write my if statement. I'm going to write it in brief. If 2x minus 1 is a factor, then f of half should be equals to 0. I have written my if statement. If 2x minus 1 is a factor of 2x cubed plus 3x squared plus 10x minus 6, then f of half should be equals to 0. Now, I get a mark for writing my if statement. Then I go to do the substitution now to prove what exactly is f of half. Now f of half, it means every place where I have an x, I'm putting a half in this function here. So this is 2 half cubed plus a 3, half being squared plus a 10 by half minus a 6. I punch in my calculator. If I don't get a 0, then I can say, no, it's not a factor. But if I get a 0, it means it is a factor. Let's see. 2 half cubed plus 3 half squared plus a 10 times the half minus a 6. We indeed get a 0. Now, after this, I write my conclusion. So I should get a mark for doing this. Then I write my conclusion. Therefore, 2x minus 1 is a factor. Okay, 2x minus 1 is indeed a factor of it is indeed a factor of 2x cubed plus 3x squared plus 10x minus a 6. Then I just want to briefly explain the applications of this. Where do we use the factor theorem? There are a few applications that I'm going to mention where we can use the factor theorem. So the applications of this factor theorem. Because some people will be like, why should we know the factor theorem? There is a reason why you should know the factor theorem. If you are factorizing polynomials, like you are factorizing a cubic function, you may want to get one of the linear factors, and to get them, you may use some, I'll call it an educated guess, where you guess that some linear factor is indeed a factor. Then you prove it using the factor theorem. So one of the applications is factorization of polynomials. If you're factorizing a polynomial, you may indeed have to use the factor theorem. Sometimes you may use it on solving an equation. We can also use it for solving for unknowns. See, I can say to you, this and this is a factor of that one, and you go to that function and you find that there is a missing letter or a missing variable that you don't know, and then you're going to apply the factor theorem sort of like in reverse to solve for that unknown. That's where you usually apply the factor theorem, especially in the factorization of polynomials, which you do often in many topics in mathematics. So please just make yourself comfortable in using the factor theorem. It is quite a straightforward thing. You write your if statement, find your A, do the substitution, then write your conclusion. If you don't get a 0 after substituting, it means it is not a factor. If you get a 0, then you can conclude that it is indeed a factor. Thank you for watching the video. If you have any questions or any comments, write in the comment section below. I will respond to you. Otherwise, thank you.